Hi, my name is Andy, and this is an introduction and high-level overview to the Shaderfrog 2.0 graph editor. We're going to start by going to shaderfrog.com. If you go directly here, you'll be taken to the older version of the website, and this tutorial is for the newer version of the website. So you can either directly go to /2, or you can click on this link here in the banner to take you to the Shaderfrog 2.0 graph editor. There are a bunch of shaders here you can look at and browse through on the homepage. We're going to get started by creating a new Three.js shader. To call out right now, the Babylon and Play Canvas editors are not working well, so only the Three.js editor is currently operating well. So we're going to click on a new shader here, and we're in the editor now, and I'm going to walk you through the panes and functions of the editor. On the right side is your preview pane. You can use the mouse to pan, you can zoom in and out, you can right-click and drag around the object. You can preview different types of objects here. You can toggle some debugging things like tangents and wireframes. You can modify the scene over here. You can change the background. You can change some properties of the renderer. And if there are Three.js materials in this scene, you can also change the lighting. You can see in this case nothing is happening right now because there are no Three.js lights in the scene. All of these settings here are optional settings generally on Three.js scenes and on the renderer. You are not limited to using these if you do end up using this shader in your own game or application. These are just ones that Shaderfrog provides to help preview your shader on different types of geometries and things like that. For the geometries you choose over here, you can also choose the number of vertices on the sphere or whatever object you have selected to make it more easy to see your shader. On the left side are the list of shaders that you can use in your graph. These are shaders that have a special tag on them called composable, and they also, you can include your own shaders if you've created any by selecting include my own effects here. We're going to show how to use these shaders in the graph a little bit later in this tutorial. At the heart of Shaderfrog is this thing in the middle called the hybrid graph editor. So this is a combination of a graph editor and a code editor. To start, there are two special nodes. One is the green nodes are fragment shader nodes, and the red nodes are vertex shader nodes. The two special nodes are the two output nodes, one for fragments and one for vertices. As an aside, to get the most out of Shaderfrog, it's going to be very beneficial if you have some GLSL shader programming knowledge ahead of time. So we're looking at a graph editor right now, and you can see that there are two nodes plugged into the output, and there's also this gray dotted line between these two. This indicates that these two shaders have a hidden link between them, that there is a fragment and a vertex shader that are linked together. This affords some special properties of Shaderfrog related to how the nodes are composed together in the end. So in order to edit some of these nodes, you can double click on them, or you can click on the gear and you can hit edit source. When you click on that, you are taken to the code editor. So we've just essentially clicked into a node, you've clicked into the fragment node. You can also use the browser over here to click on its corresponding vertex node. And the code here is GLSL. Because we hit new Three.js shader, we get access to these default uniforms and attributes that Three.js provides out of the box. The ones listed here are not all of the ones that are available from Three.js, but you can go look up what Three.js has in the shaders themselves. There are many examples that you can look at on the homepage. One that's going to be useful for us to look at is this image boilerplate node here as a shader. So I'm going to go look at this source code. I'm going to go grab it and copy it into our shader, and you can do the same. But you can see this exposes some of the common attributes that we might want in a shader, like the UV, the position of the vertex, the normal, and things like that. So I'm going to go copy this back into our vertex shader over here, and then I'm going to go do the same for the fragment shader. I'm going to copy that into the fragment node. You can see that there's one tab open here in the code editor. And then I'm going to hit compile here, or you can also hit control single quote to compile. As an aside, I'm going to save this shader, but you should also know that you can't save a shader until you're logged in. So you probably want to create an account and log in before you start this process. I just hit save. It gave the shader a a default name, which you can edit up here. So I'm going to enter shader demo. I'm going to close this and hit save again on the top right. There's many missing features of the editors. The shader does not auto-save. If you close this tab, it's not going to warn you to save before you leave. So just keep that in mind while you're editing shaders. So I pasted in that image source code here to this shader. And if you're familiar with GLSL, you can see that we're taking in an image sampler, and then we're just looking up the UV coordinates of this image sampler. We're getting the vector 4, red, green, blue, and alpha of this texture, and we're putting it onto the object, and we're essentially hard-coding the alpha as 1, so the object is never transparent. You can see this looks a little wonky because there is no image data here. We're going to go back to the graph, and this is where the hybrid graph concept comes in. So you can see in our fragment shader node, it created a new input based on the image texture. You can also see it created a code input that we're going to look at a little bit later. For now, we're going to focus on this image one. And so if I go back to this shader, I just double-clicked on that green node. You can see that this uniform input named image was automatically populated as an input here in the graph editor. So now I'm going to add a new image to go into this texture. And you can do this by two ways. You can either right-click anywhere on the graph or just hit the A key. Oh, maybe it's Shift A, excuse me, Shift A. And then you can add a data texture node, or even easier, you can click on the input here, drag it out, and then create a new image node. So I'm about to add an image uniform to this shader, and this is standard uniform stuff in Three.js. This is the same as doing material.uniform.value equals Three.js texture. So I'm going to click on choose the texture here. It's going to open the texture browser on the bottom. I'm going to expand this a little bit so it's easier to browse. And while I have this node selected here, you can see its outline. I can go scroll through these textures. Click on one here, and you can see it added that image to our uniform. If you are a pro user, you can see some of these textures are labeled with high res. You can click on this one, and then you can select the 4K dropdown that's available to pro users, and you can see this is a little bit higher quality and higher resolution. I'm going to close this image browser for the moment, and now you can see we have a textured image here on the shader. I'm going to save it again for good measure. So this is the really high-level overview of Shaderfrog, but the real power of this tool comes with the ability to compose shaders together. So what does that mean? What does it mean to compose a shader? It's kind of a unique concept to Shaderfrog and sort of the whole reason that I created this hybrid graph idea. I'm going to click back into this fragment node for a second. If you look at this, it's a shader program. It has a main function that returns nothing. It has a void statement, and it assigns to this global glfrag color variable. And this is a standard shader concept, but this thing is getting plugged into the output node. And I don't think you can see the source code of the output node. If you click on it, it doesn't do anything. But this is, what Shaderfrog is doing here is it's taking this shader program and it's promoting it to a module. And what I'm going to do is I'm going to click on this fragment output tab. These two tabs, Vertex output and fragment output, contain the final compiled source code of Shaderfrog. This is a super useful tab to see what Shaderfrog is doing in the end. So you can see it took my main function of my, my fragment shader, and it converted it to a function that returns a vector 4. So now it's vector 4 main fragment, and it returns my, my texture variable output. And it created a new main function that then assigns this new global out variable, frag out, to the call of this function. When you're in these two vertex and fragment nodes, you can do something very useful, which is you can edit the source code here. So I can make this darker, for example, by -0.5. I don't have to save anything. It automatically updates here. You can't save what's in this panel. This will automatically get overwritten when you recompile the graph. So if I compile again, for example, it'll undo that. But you can go play around in here and debug a little bit. So I could like double this, for example, RGB, or I could GR, just do whatever I want in this output thing for debugging. This might not look that interesting for a single shader, but what I'm going to do is now start to look at these shaders here on the sidebar. So if I click here on the graph and I click on a shader over here, nothing happens. The Shaderfrog UI leaves a little bit to be desired. So first what I'm going to do is I'm going to pick any of these shaders. Let's try this matrix one. I'm going to drag it into the graph here. The graph turns green, and I'm going to drop it into the graph. Nothing happened. But the next thing I want to show you here is this fragment node has a code input for the image. What does that mean? Well, let's just try it. So first of all, I want to show you this matrix code here that I dragged in. It does a bunch of stuff, but it's the same concept where there's a main function that returns nothing and assigns to the global GL frag color shader variable. I'm going to go back to the graph, and I'm going to drag in the output of this into the code node of the fragment shader, and let's see what happens. Interesting. So it is showing this matrix code shader going through this fragment one. I'm also going to do something different. I'm going to drag this node directly into the output of the shader, and you can see it looks exactly the same. I'm going to then reconnect this one over here. Shaderfrog does let you have two outputs. You can see that there's two things coming out of here. You can also select this line and then hit delete to delete it. And now you can see there's nothing plugged into the output node. I'm going to plug this back in here. So right now it sort of looks like it's passing through the shader, but let's go back into this image shader and let's do something like, let's make this darker. So let's make it minus 0.5. And you can see this thing got darker over here. So somehow Shaderfrog is saying, I'm going to take this image uniform and I'm going to let this shader get plugged into that thing. So what on earth is happening? Well, let's go back to our compiled source code tab to see what's actually happening. Shaderfrog took all of these shaders and it combined them together into the global namespace. So you can see it made a main function for the matrix code shader, and it made a main function for the fragment shader. And in our fragment shader, remember, we looked up that image and assigned the result to color. Well, in the end, it actually called the main function, replaced that call to the texture lookup, assigned it to call, and now we're using this. Telling the story at a little more simple of a level, you can now use a shader as an input to another shader's image. It doesn't have to only be images. It can be to any part of the shader. I'm going to go look at the next part, which is the configuration of this shader, of this node, I mean. I'm going to hit edit configuration here, and now we can see a little bit of the guts of how Shaderfrog works. The way that Shaderfrog finds these inputs, like this code input here, if I go back to edit configuration, or if I just click on the GLSL tab and go to the fragment config tab, you can see that there's a section called strategies. And a strategy is described here. It's a searching function applied to your source code. So we have a strategy to find all uniforms in this shader, and a strategy to find all texture 2D calls in the shader. So if I go back to the fragment source code, you can see there's a texture 2D call. What Shaderfrog is doing is it's saying, okay, I'm going to look for all texture calls like this one. Our texture is also the newer version of texture 2D, which is why it says texture 2D in that config. And it's going to say, I can mark this as replaceable now. So this is going to become the input to the shader. Whenever you plug something in to that input, it'll overwrite this. And we can go look at the output tab again. It'll say, I'll overwrite this texture 2D call with whatever you plug into it. So in this case, it's modularizing the matrix code function, and then it's inserting the call to that matrix function here. There are also other types of source code nodes you can add to the graph. So I'm going to go add a fragment node. It has a main function, but I'm actually just going to put in parentheses, let's say vector 4, red is going to be 100%, green, blue, and then alpha. I'm also going to click on this source code node config section up here. I'm going to rename this to input color. I am going to mark this as a different type of source code. So I'm going to mark this as a GLSL expression down here. And then I'm going to hit compile. I'm going to go back to the graph, and I'm going to plug in this input color to my code node. And you can see it's now going to take this GLSL here, this vec4 GLSL. I'm going to go back to the fragment output. And you can see it is essentially inlining that GLSL expression directly into Shaderfrog. You can do a few more things with these different types of fragment nodes, but this is just an example of the composability of Shaderfrog. Okay, I'm going to go back to the graph and let's try to make this a little bit more interesting. So I'm going to click on the fragment node and I'm going to delete it, which deletes all of that node and its downstream dependencies. I'm going to click on delete on the matrix node as well. And then I'm going to hit Shift A again, and I'm going to add a Three.js physical material to the graph. This is a standard Three.js material here. I'm going to plug in both the position, or the fragment and the vertex output. To make this a little more interesting, I'm going to drag down the roughness so it's a little bit shiny. I'm going to increase the metalness here. And these are all standard Three.js properties. They're just being modified in a graph editor. You can see that there's a section here on the node called properties, and that is the Three.js material properties. There's also a section called uniforms, but we're going to ignore that for the moment. So Shaderfrog lets you compose these shaders arbitrarily. So now that we have these lighting effects here in place, let's go drag in another node here to the graph, like circuit grid. You can see it does the same thing. It pulls in the circuit grid, fragment, and vertex shaders. I'm going to go plug this into the texture node of the mesh physical material. And look at that. It has this nice procedural effect created as the texture. You can also, I'm going to delete this first. I'm going to click on the edge and delete it. You can plug this into other properties that take a texture, like the normal map. So this looks a little odd, but this thing is getting applied to the normal map of the shader. I'm going to click on this line again and delete it. And plug it back into the texture. Shaderfrog crashed, so I'm picking back up where I left off. If you double click on the mesh physical material, you can see the Three.js compiled source code material for a mesh physical material here in the end. You can't modify this, it's read only because Three.js generates it, but you can poke around here to see what some of the Three.js uniforms are, some of the functions they expose, things like that. If I go back to the graph and I plug in the circuit grid back into the texture, and then go back to the GLSL editor and look at the fragment output, let's go look in here for circuit just to go find it. Oh, actually the search I don't think automatically scrolls. Oh, yes it does. So you can see it used the main circuit grid function here. Or it modularized the main circuit grid node and created a main function that returns a value like we saw before. And then if I go search for this main function call, what this is doing is it's actually plugging in the output of this shader into the middle of the Three.js source code. So Three.js is saying, hey, if you want to use the texture property, it's actually going to overwrite this assignment to this variable in the guts of Three.js source code, GLSL, called sample diffused color. And it's going to inline your shader call here. So that's the way that Shaderfrog works. And again, you can live edit this thing in the end, so I could go modify the brightness of the diffuse map and things like that. And then when I recompile the graph, it will reset it back to the original one. Now that we have a Three.js physical material in the graph, by the way, we can actually go look at the lights. We can add multiple point lights. We can turn on the lighting helpers so we can see them, and I'm not sure if you can see them reflecting in the scene, but you can see the lights moving around now. You can switch the lighting types. And again, it doesn't really show up that well. You're not really limited to these types of lights, but these are just ones that are used for debugging your shader and looking at the different types of lighting materials. We're going to look a little bit more at the power of Shaderfrog now, which is quick shader iteration. So we have a whole bunch of shaders here on the left sidebar. And if we want to go, look at different types of procedural textures on this material, we could do something like drag in a new one, like this one, and we could drag this into the texture map and replace it. And sure, that's great. It's a little bit time consuming. Or I'm just going to delete the circuit grid one. I can click on the green node here, and I can then choose any shader here on the sidebar, and you can see this text showed up, replace electric wires with, and then you can choose anything over here. So let's go choose, I don't know, this nice procedural spiral pattern. This is still selected, so I can keep clicking around. I can now look at this one, or this one, or this one. Oh, okay. So now you can see a little bit of the power of Shaderfrog here. I can really quickly iterate on shader designs with a single click. As part of this overall tutorial, we have only been operating so far on the fragment shader, which is the pixel color, or the fragment of the screen that's being colorized in the end. But Shaderfrog also supports doing this whole same process with Vertex shaders. So I am going to zoom out a little bit, and remember how we saw the code section of inputs of shaders where you can replace the source code of shaders. So I'm going to drag in the red node now, this vertex output, into the position attribute, or not position attribute, the position node of the mesh physical material. And nothing happens because right now this node isn't doing anything. And let's go look at it for a second. This shader is assigning, similar to the fragment, it's assigning to the GL position global vertex variable, and it's doing all the math needed to properly place this vertex in screen space. We're going to look at how they're composed in a moment in the end, but now that I have this plugged in, I'm going to go reselect the green node. You usually want to have the green one selected. And I'm going to go select a shader that has a vertex animation along with it. So let's click on wiggly rings as an example, see what it does. Oh, interesting. So now the vertices of this Three.js shader are also getting animated. Double click on the wiggly rings node, and this shader here is also assigning to the GL position in the end. It's modifying the overall thing here. So what Shaderfrog is doing is it's essentially extracting this position variable and then composing that into the Three.js shader. Let's see if we can go see that in the vertex output. This might be a little odd to look at. So I'll go look at the mesh physical material. So this is Three.js's vertex shader in the end here, and you can see that it is, where is it? Yeah, it's getting the position from the wiggly rings vertex output. So it's taking this wiggly rings shader, it's modularizing the main function, and it's saying, I'm going to go extract that position variable, and I'm going to make that the return of my function. So that's how the vertex shaders are composed. It extracts the position, and then you can start to stack the positions into Shaderfrog. One useful debugging thing that you can also do is, similar to what you did before, you can bypass the Three.js output and just plug your shader directly into the output here, and you can see this is the raw shader. No, I don't know why that failed. I wonder why that failed. I just deleted, I deleted some duplicate edges. Sometimes the edges confuse Shaderfrog. So this is the raw shader here, and it can be useful for just debugging the shader source code as needed. But I'm going to go plug this back into the position, and I'm going to go plug this back into the texture map. Cool. And then let's keep going. Let's keep modifying the input shader here. What other ones have vertices? This corkscrew effect, you probably can't see that. Maybe this one, Pearl and Warp. Ooh, yeah, now we're talking. This is also a good time to start modifying the number of vertices on the object to make the preview a little bit more smooth. Again, you can just start cycling through these with a single mouse click. Here's the fireball one. That looks pretty cool. And yeah, I think that's the primary overview of Shaderfrog. There are plenty of other interesting examples to look at on the homepage. Maybe another illustrative one is another example of a shader where, if I remove these inputs here, you can plug this in because we need a vertex. So this is an edge detection shader, and you can see by default this is taking in a image uniform, like we started off this whole program with initially, and this is finding the edges of these inputs. But you can also then take this effect that takes in an input image uniform, and you can start plugging in shaders to these things. And now you can start to see these sort of effect composition things going on, which is pretty cool in Shaderfrog. And then plenty of examples to choose from. The graphs can get pretty complex, but also fairly readable. Here is, for example, some shenanigans done to get this sort of warped effect done on the rocks only, but not on the underlying dirt here in this texture. And one last thing I want to call out here in the hybrid graph editor is, if I zoom out in this graph, this is actually a pretty small graph compared to a traditional graph editor. You can see that there's only, 1, 2, 3 fragment shader nodes here, and all the blue nodes are just, values. They're just image uniform values, so nothing too complex. In a traditional graph editor, all of these nodes would contain individual GLSL pieces of math like vector for, plus, add, minus. But because this node can contain a full program, this thing is a pretty self-contained thing. You can have only one node in this graph that contains all of this logic. And all of these nodes are from the user store of shaders, basically. The more shaders that people write in Shaderfrog, the more options you have as inputs to your own shader. All right, I think that is a high-level overview, whirlwind tour of Shaderfrog 2.0. Please comment with any questions that you have. Thank you very much.